Hi guys, this is Pre-Algebra Lesson 2-3. Compare and order real numbers. In this lesson, we'll be able to compare and order rational and irrational numbers. So last lesson, we learned what irrational numbers are, and we knew how to categorize how to rational and irrational numbers by the end of the lesson. So continuing off of that, we're going to compare and order real numbers. From least to greatest or greatest to least, we're going to be able to compare and order them. So let's start with solving this gusset. Courtney and Malik are buying a rug to fit in a 50 square foot space. Which rug should they purchase? Explain. So if you look at this poster, it says $99 rug sale. And we got different kinds of rugs, right? This rug, the first rug, has dimensions of 7 feet times 7 feet. And then the next one is a circle. It has an 8 feet diameter. And the third one is a rectangle, 6 feet by 8.5 feet. So Rug Emporium has three different kinds of rugs, right? Which rug should they purchase if they want more materials, right? They're all $99. So if you want more area to cover your floor, then you want to figure out the areas for all of them, right? So let's figure out the areas for each rug. So area for that is 7 times 7, which is 49 feet square, right? And then area for the second one is, what's the area of a circle? Is pi r square, right? And so this is the diameter. What is your radius? Diameter divided by half. So that's gonna be 4. And your area of the circle is pi 4 square. And that's going to be about 50.24 feet square. Yeah, do you guys know that pi equals about 3.14? Yeah, if not, you can also find pi in a lot of calculators. You probably have to press shift something or second something. So pi is going to be there in the calculator if you have a scientific calculator. So you can also search for pi and calculate it with your calculator and round it up your decimal. Okay, your third rug will have an area of 6 feet times 8.5 feet. And that's gonna be 48 plus 6 times half. Or you can change this mixed fraction into an improper fraction, 17 times 6, and you divide it by half. Either way it works. And that's a multiplication, not a mixed number. So that's plus 3. And that's going to be 51 feet. And so which area is the greatest? 51. So you should choose, so that's 1, 2, 3. You should choose rug 3 if you want to get the rug with the most area. And the square rug, only the square rug has an area less than 50 square feet. So if they want to fit 50 square foot space, it has to be less than 50 square foot. So actually, I would buy the biggest one, but Courtney and Malik would probably buy the smallest one here because that's the only carpet that fits into the 50 square foot space. So yeah, depends on who depends on who is wanting what, right? So only the square root has an area less than 50 square feet. So it is the route Courtney and Malik should buy. Okay, focus on math practices. How did you decide which route Courtney and Malik should purchase? By figuring out the area, right? And comparing them with what they need. So we can say, since all of the rugs are the same price, find the one that is the best value. The round and rectangular rugs are larger than the square rug, so they are a better value. But they are each too large to fit the area Courtney and Malik have, right? So then we have to decide that the square rug is the only choice for them. Yeah, that was our thought process exactly. So they'll probably buy the square rug. If not, they'll probably come back and purchase another one or change them. Let's move on to the next page. So the lesson essential question is, how can you compare and order rational and irrational numbers? Look at example 1, approximate an irrational number. Darcy wants to add the ribbon shown along the diagonal of the rectangular flag she is designing. Does Darcy have enough ribbon? Explain. All right. So she's gonna design this flag. She has this ribbon. She's gonna add this along the diagonal here. Does she have enough ribbon? So is it enough to cover this hypotenuse of this triangle, which is square root of 74? We just need to know if square root of 74 is smaller or same as 8.5, right? Because we know that the ribbon is going to be 8.5 feet, which means we're going to approximate square root of 74 using perfect squares. So we're going to approximate where they are at on the number line using the perfect squares. 8 is the answer to square root of 64. Square root of 64 is 8 because 8 squared is 64. And that's exactly what we're doing when we have square root. Okay, so another notation that could help you figure out what your whole number is for that square root. You can rewrite 64 into a square. 8 times 8 is 64. So 8 squared is 64, and square and the square root cancel each other out. So that means it's an 8, okay? Same thing for 81. 81 could be written as 9 times 9, which is 9 squared. And squares and square roots are the opposite, so they cancel each other out, which means you just have a whole number 9. 74 is in the square root. 74 is greater than 64, less than 81. So your answer is probably going to be greater than 8, less than 9. 74 is closer to 81, so it's a little bit closer. It's going to be a little bit closer to 9 than it is to 8. And then you're going to find a better approximation by squaring decimals between 8 and 9. Because if you just know, oh, it's going to be between 8 and 9, and that's going to be 8 point something. But the ribbon is exactly 8.5. So how do you know if it's going to be greater or less than or equal to, right? So you need to be better at approximating it, more accurate, right? So you're going to try to multiply the decimals. So you can multiply, you can start multiplying 8.5 times 8.5. So 8.5 squared is 72.25. And compare that with 74. 72.25 is less than 74. So the decimal could be greater. 8.6 times 8.6 is 73.96. And that's really close to 74, right? 73.96. It's like 0.04 away from 74. So it's just a little bit smaller than 74. Yeah? So it's gonna be around 8.6. So the length of the diagonal is about 8.6. It's definitely greater than 8.5. So you can say that she doesn't have enough ribbon. Ribbon is a little bit shorter than the diagonal because it's 8.5. Okay, so compare your rational numbers with irrational numbers using approximation. So in this type of problem, you won't be able to use your calculator to figure out what exactly your square root is. You need to be able to figure out the number and approximate your square roots by yourself on your own. So let's try this question. Between which two whole numbers is square root 12? So fill in these blanks to compare between which numbers it will be. Come back when you're ready for answers. Try to get as approximate as you can. Okay, first of all, what is 12 between? So here you're supposed to write perfect squares. So between which two perfect squares would 12 be around? So you're gonna look at the perfect squares, right? 3 square is 9. 4 square is 16. 5 square is 25. 12 is between which two numbers here? Between 9 and 16, right? It's greater than 9, it's less than 16, so it's between those two perfect squares. And so, square root 12 will be between square root 9 and square root 16. Does that make sense? Yeah. And so, square root 9 is 3, square root 16 is 4, so square root 12 is between 3 and 4. So between which two whole numbers is square root 12? You can say 3 and 4. If you got more accurate answer, approximate answer than that, good for you. Let's look at convince me. Which of the two numbers is a better estimate for square root 12? As explained. So is square root 12 closer to 3 or 4? How do you know? You look at 12. Is 12 closer to 16 or 9 is what you would compare with. So 12 is 3 units away from 9 and 4 units away from 16. So it's definitely a little bit closer to 9. So square root 12 is gonna be closer to 3. So you can say 12 is closer to 9 than to 16. So square root 12 is closer to square root 9 or 3. Okay, this is how you approximate your values for square roots that are not perfect squares. Let's look at example 2. Compare irrational numbers. Let's compare square root 32 and 5.51326 ... They are both irrational numbers. So how do we compare them? Let's plot each number at its approximate location on the number line. So step 1, you're going to approximate square root 32 by using perfect squares just like we did in example 1. So 32 is between the perfect squares 25 and 36. So square root 25 is 5, square root 36 is 6. So square root 32 is going to be between 5 and 6. And so you can start figuring it out by multiplying your decimals that are between 5 and 6. 5.5 times 5.5 is 30.25. 30.25 is less than 32, so you can increase your decimal. 5.6 times 5.6 is 31.36. It's still less than 32. Let's try the next one. 5.7 square is 32.49, and now it's bigger than 32. So it's definitely between 5.6 and 5.7, right? So now we have a better approximation. Square root 32 is between 5.6 and 5.7. And then you can approximate the next number, 5.5132.6 is a rational number by rounding to the nearest tenth. Because we have approximated our square root 32 to the tenths, we're going to approximate our decimal here, the rational decimal, into to the tenths. So that's about 5.5. So if square root 32 is between 5.6 and 5.7, it's going to be greater than 5.6, which means it's going to be greater than 5.5, right? So on the number line, it's probably going to look like that. And so square root 32 is greater than 5.51326, ... Okay, this is how you would approximate and compare the two irrational numbers. If your answers are too close, you need to get more and more you have to get better approximation. Maybe you might have to go into the hundreds, you might have to go into the thousands, but hopefully we don't give you questions that require you to approximate by the thousands. Okay, but you keep guessing until you get closer and closer to your squares. At example 3, compare and order rational and irrational numbers. Now we have many numbers to compare. We're going to compare and order the numbers below. Pi squared, 9 1/2, 9.8, 9.5 repeated, square root 94. So as soon as you see that, you should be able to identify which are rational, which are irrational numbers, right? Pi is an irrational number. Square root 94 is not a perfect square, so that's an irrational number. Everything else could be written as a fraction. Repeated decimals could be written as fractions, so all three of these numbers are rational numbers. We're going to use rational approximation to estimate the values of irrational numbers. So pi is about 3.14, so you multiply that 2 times to get about 9.8596. And that's already rounded up. Your pi is not just 3.14, it's not terminating decimal, but it's approximately 3.14. So you can use that to approximate your pi square. 9 1/2 is 9.5, 9.8 is 9.8, 9.5 repeated could be 9.5555 ... Square root 94, you're gonna compare it using the perfect squares, right? 9 squared is 81. So square root 81 should be less than square root 94. What's the next square? Perfect square? 100. 10 square is 100. So 94 is less than 100, greater than 84. So it's between 9 and 10. So it's 9 point something. So you're going to start multiplying your decimals between 9 and 10 in order to get closer and closer. The closest you can get is 9.7. So step 2, you're going to plot each approximation on the number line, and you already see that they are in order. So 9 1/2 is going to be the least one, and then in this order gets greater and greater. Pi squared is the greatest one. But they're all between 9 and 10. So you need to be very accurate about it. You need approximation. Alright, let's look at try number 3. 3. Okay. This is the last try. Let's compare and order the following numbers. See if you can compare and order the following numbers from least to greatest. See if you can do it by yourself. Come back when you're ready for answers. Okay, are you guys ready? Alright, first of all, square root 11. That is the hardest one here out of the others, right? So you need approximation skills to approximate your square root 11 between your perfect squares, and then you need a better approximation by guessing and checking the decimals between those two whole numbers. So let's first look at the perfect squares, right? 11 is between which perfect squares? 3 squared is 9, right? 4 squared is 16. 2 squared is 4. So 11 is between 9 and 16. Square root, okay. 11 is between 9 and 16. So square root 9 is less than square root 11, and that's less than square root 16, which means square root 11 is between the whole numbers 3 and 4. So you can start guessing and checking your decimals. Okay, 3.3 squared is 10.89, and 3.4 squared is 11.56. So 11 is between 10.89 and 11.56, which means square root 11 should be between 3.3 and 3.4. And I think that's enough, right? Because 2 and 1/4 in decimal is 2.25. And negative 2.5 is negative, right? And negative 3.97621 is it's less than negative 2.5 because it's further away from 0. So order these numbers from least to greatest. Negative 3.97621 ... is definitely the least, greatest, and then negative 2.5. And then all the others are positive. So which one comes first? Square root 11 is between 3.3 and 3.4. So it's probably about 3.3 something, right? So that means it's greater than 2.25. So 2.25 comes later, but we need to write the original form. So let's write 2 and 1/4. And then which one is greater? 3.6 repeated or square root 11? Square root 11. And then 3.6 repeated. So that would be our answer. See if you got it all correctly. If you didn't, if you mixed up some numbers and orders, please change them, correct them. But if you got everything correct, good job. Let's summarize our lesson. To compare rational and irrational numbers, you must first find the rational approximations of the irrational numbers. Square root 2 is between 1 and 2. And then you're going to approximate irrational numbers using perfect squares or by rounding. And then look at all the decimals between 1 and 2, the whole numbers 1 and 2. You're going to square them to see between which of these more approximate decimals square root 2 lies. And then you have more approximate answer. Okay guys, that was lesson 2-3, comparing and ordering real numbers. If you have any more questions, please ask us in our math class. Otherwise, we'll continue with lesson 4, evaluating square roots and cube roots in the next video. That's gonna be fun. Alright, bye!